Hello and welcome to TidyX episode 179, TidyX screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward. Today, episode 179, we're going to be re-engineering a funny little video from Instagram detailing how many cans of SpaghettiOs you'll need. So
Yeah,
this has a bunch of different things in it, like how to deal with lists and print outputs and write functions. So a number of things that we do on a regular basis applied to
it's a
this
little
silly
silly.
little silly little problem. So yeah, if you want to know more about functions and lists and sort of the whole functional programming scene, be sure to like and subscribe on the YouTube channel and drop the questions and comments down below.
Yeah, do it. Yeah, I'll call out to Abstract Taylor or Tyler for making this video. It made me really laugh when it came across my feed, and I sent it to Patrick. And I was like, "Oh, we should definitely do this and see what we see if we can come up with the same answers and just kind of throw it together and just have a little bit of fun, right? Because we're not always doing incredibly serious stuff. So let's see what we can do with the code here and see if we can solve Tyler's problem of how many cans of SpaghettiOs are required to write the Lord of the Rings. And this is the A to Z SpaghettiOs. And so you've got all the different noodles, A, B, C, D, all the way to Z. It's kind of fun. So what we're going to do first is we're going to load up library tidyverse. Oh, by the way, the link to the reel is right there. So go check that out. Give him a view. Um, and so in Tyler's video, he puts screenshots of the code that he's running to calculate the number of cans he'll need. But he went through and manually counted, as you saw in the video, the total number of letters in how many A's, B's, C's exist in the cans of SpaghettiOs that he poured out. He didn't tell us. He didn't have the distribution of can one had 28 A's and the third can had 30 A's. He didn't break that down. He just gave us the average here. Um, and so I threw that into he showed it in the screen. I threw it into Gemini. That's Google's chatbot AI powered chatbot, and said, "Hey, given this picture, I took a screenshot of the table that he made. Give me the tibble that would generate the output there." I didn't really want to go through and manually do it, and it actually did a pretty good job. I did mess up a few of the values, so the actual tech or the numbers themselves were correct in percent total and times. It was just the letters it messed up on. I had some issues with the OCR there, so I went back and corrected all those. So this is the Tyler's can count, so we can print that out. And so we can see that Tyler had 27 A's, 28 B's, 29 C's, and then he has a percent total there. We ended up not really using the percent total. That's not really what we're trying to calculate here. Um, but it was in there, so we included it. And the same sort of thing we did for the Lord of the Rings count. So he took the text of Lord of the Rings, converted it all into lowercase. If he in his video he kind of scrolls through his code really quickly, and so I would pause it and look at it and see what it was doing. So basically, he just took all the text of the Lord of the Rings, turned it all lowercase, removed any non alphabetic or A through Z values, and threw those away, and just recreated this. And so I pulled that out and printed that out. So now we've got what is the distribution of A through Z in a can of SpaghettiOs, and we've got the number of letters and the number of times each letter appears in the Lord of the Rings trilogy. This is all of them. This is not including The Hobbit. These are the three books from the Lord of the Rings. So I also verified that my numbers were correct here by calling the sum on the counts that I pulled from his video, and it matched the 2,261,081 letters. So now that we've got all that information, let's go through and calculate how many cans of SpaghettiOs we'd need in order to write the Lord of the Rings. Patrick, do you want to take us through this function?
Yeah, so this is a function that is going to take two inputs. One is the can count data frame, and one is the book count data frame. And these are just generic. They're not specific to Lord of the Rings because we can then use this for any book if should you want to know how many cans of SpaghettiOs you need to spell out the book, which is an important problem. So within this function, you pass those two bits of information. The first move is to create a can and booked data frame, which is just joining together the can data frame and the book data frame. We're joining by letter, so that's the key between the two data sets that we're going to join on. And left join, inner join, right join, they offer us this nice little suffix argument, which basically says, hey, if you want to be explicit about your columns, let us know how you want us to append, either to the front or to the end of them, information. And so in this case, on the left-sided data frame, the can count, we're going to do underscore can. And on the right-sided data frame, we're going to do underscore book. Is there a way that they could just see the head of this?
Yeah, we can do this real quick, and we can say this is Tyler
Yeah, there we go.
can count, and then this is Tyler LOTR.
There we go. Yeah, so you can see that letter was the key that we joined on, so it's going to be the same. Then we have the percent total can, and we have the percent total book, and we have the number of letters in each can and the number of letters in each book. So that's the first kind of starting data frame. The next data frame helps us understand how many cans we potentially need in order to make this SpaghettiO book work. So we're going to take the cans data frame, and we're going to add a new column with the mutate function, and it's called n times. So we're dividing the n book by the n can. So the number of letters of each individual letter in the book divided by the number of times it appears in the can. Yeah. So that kind of gives us a little bit of a ratio of the letters in the book to the letters in the can. Then we're going to add another column called ncans, and we're use the ceiling function. And what the ceiling function is doing is it's basically just rounding everything up, because you can't have half a can or a third of a letter or something like that.
Grocery stores don't like us buying half
Yeah.
of a can of SpaghettiOs. They might look at you a little bit funny and ask you to leave in a not so nice way.
So ceiling always rounds up. If we used
Yes,
round with 0 digits, we'd end up with rounding down. So like 2.1 would have rounded down to 2, which it's in something like this, it's probably safer to round up because you can't take away. You can only add another can to the shopping cart, right?
exactly.
So once we've done that rounding, we're going to pull that column n cans. So remember, this is just going to yank that column out into its own little vector. And then we're going to get the max of that pull n cans. And this is going to be called the number of cans needed. The
Because we
next,
can't, because we need at least that number of cans for that letter, right? And therefore we can't buy less cans than that to successfully write out the full book. And so
correct.
that the maximum, the letter that needs the most number of cans is the minimum number of cans we can buy in order to write the book.
Yes,
Yes.
correct. Yeah. The next piece of this function is called leftover noodles. So you're going to buy a bunch of cans and you're going to get leftover noodles once you've spelled out the book. And especially if you look at the data frame of the percentage of letters in each can, if we looked at the entire data frame, you'd see like 28, 27, 29, but the letter O in a SpaghettiO can is really, really overpopulated, like 400. So there you go. It's like 441 O's. So 30 make up 37% of the letters. And then everything else is sort of pretty flat, pretty similar. So you're going to end up with a whole bunch of leftover noodles because, like, as you can see, the letter Z, every can on average, it might produce 36, around 36 Z's, but that only makes up 4% of the letters in Lord of the Rings. So there's not a ton of that letter being used. So this leftover noodles function is going to do that. It's going to take the canon book counts data frame. We're going to add a new column called n noodles, which is the number of cans multiplied by the number of cans needed.
So and cans is the number of letters, number of times that noodle appears in the can.
Yep.
It's yeah. I should have labeled that a little bit differently, but it is what it is.
Yep, yep. Then we're going to mutate, add another column called n leftover, which is the number of noodles minus the number of letters in the book. So again, we're going to buy a bunch of cans, and some of those letters are going to be overrepresented. So the difference between them is going to be what's left over. And then we just select out letter and n leftover. So this is basically giving us the final result of that data frame without all of the other information, which at this point for that data frame is largely superfluous. We don't need that information in order to tell us what we need. So this comes down to then let's get some of the vitals here. At $1.39 per can times the number of cans per needed is going to give us our average cost to do this project. We might be interested in how many calories this is going to how many calories will be required for us to eat the book Lord of the Rings.
Because we can't let any of it go to waste.
Don't want to let it go to waste. So 200 calories per can multiplied by the number of cans needed. And then the total leftover noodles is going to be the sum of the n leftover column in that leftover noodles data frame. And we're just going to have this in the function output directly to the console. So we're going to say this is an output string, and we've pasted together the vital information with some text so that basically you know what the heck you're looking at. So total cans needed, colon, and then the information of the total cans needed. And scales is just a nice little package that helps give us like prefixes and suffixes to numbers. So like if you want dollars or you want things rounded or you want to add commas, those kinds of things. So it's basically a styling piece that we add in here. And once we've created that output string, the cat function just lets us print this out as a string. We could have typed print here, but it would have come out, I think, as like the
square one, because it's printing out the character then.
A bracket one, yeah.
Yeah.
But we don't care about that. We just want the information printed out, so we put in cat. And then maybe there's some bizarre reason why we're like, hey, we'd love to be able to store this information in case we need it for something down the road. So we're going to wrap the results in a list and wrap that list in the invisible function. And so invisible is just saying, hey, store the results in case they need it down the road and they want to call elements of this list, but don't spit it out to the console because we don't need to. We're spitting it out in this nice form called output string. So that's the function that's going to do the heavy lifting for us.
Yeah, so normally you'd see a function that has the word return, or they could have just left it like this. So oftentimes you'll see one of those two if they want to return an actual value. But when it does get returned from a function, it will automatically get printed then.
Yeah.
But if you wrap it inside of an invisible, what it'll do is it'll still allow you to return the value. So we can then capture the output of calc SpaghettiOs by assigning it to a new variable, but we don't have to if we don't want to print out that value.
Correct.
So cool. So now we've got calc SpaghettiOs. So now we can use calc SpaghettiOs on Tyler's can count and Tyler's Lord of the Ring count. And we run that, and we get, you'll need the same values that he did, roughly 9,000 cans of SpaghettiOs in order to write out the Lord of the Rings. You will need $12,200 in order to afford all those cans, and you'll roughly have 1.7 million calories that you'll have to eat. So I'm sorry, you're going to be eating that for a while. We don't let any food waste happen here. And you'll have roughly 8.1 million extra noodles floating around in your life that did not go into writing Lord of the Rings.
Yeah.
But that's not all we did, because Tyler also did calculate for Lord of the Rings how many letters exist in that text. And so we can go through, we're going to create two different functions to help us do this for now any other book that we'd want to do this for. First is calculating book letter counts. So this is given a string or a vector of strings, let's calculate the number of times each letter exists. So we're going to assume book text is a string vector. We're going to convert it all to lower. We're going to then replace this is a regex, and this is going to say if this is not A through Z, so if this is a 1, if this is a period, if this is a space, if this is just anything that is not, the letter A, B, C, D, all the way to Z in lowercase. Huck it away. Get rid of it with this guy there. So it's just don't replace it with nothing. We're going to then paste all the strings together. So if you passed a string vector that had like 5 different elements or 100 different elements, paste it all together. We're going to use str split to split every letter independently. Str split returns a list. So we're going to call unlist on that so that it returns it back and just into a vector. And we're going to call table on that. And table is a really nice function that it tabulates the frequency of every occurrence in the vector that you pass to it or data frame that you pass to it. And so table is a really nice function. We're going to then convert it into a data frame so that it has 2 columns. One is the item of interest, and the second column is frequency. So the number of times that item occurs. And we're just going to then change the names to be letter and N to match what we're using in our data set. So we've got book letter counts, and then we've got, okay, now we're going to pass in the file. We're going to write a new function, book as SpaghettiOs. Let's pretend we have the function or the book text on hand. We were able to access that. We're going to wrap all this up into a single function called book as SpaghettiOs. So we're going to read that book file, pass it into the book letter counts so we can get the counts for the book of A appeared this many times, B appeared this many times in our book. We're gonna have a number of different cats out. So we're gonna a number of different console outputs. So we're gonna say the letter counts and print out for that book how many times A, B, C, all the way through Z appeared, and go, these are the total letters that exist in this book. Then we're going to recreate that can count data frame, a SpaghettiO can count df, and run it through calc SpaghettiOs against the book count df. So this is now our new book. Get those results and invisibly return those. So now, if we ever wanted to know how many cans of SpaghettiOs it would take to write Romeo and Juliet, we now know that there are roughly 107,000 letters in Romeo and Juliet. This is based on an online source of Romeo and Juliet as a text file here. So there's going to be some extra stuff in there, and we're gonna ignore that for now. We need roughly 411 cans of SpaghettiOs, costing us $571.29. But it's only 82,000 calories. So it's a lot easier to eat Romeo and Juliet than it is the Lord of the Rings series.
This is a much more feasible project.
Much more, yes, exactly, because no food waste. And then, if we wanted to know the Odyssey by Homer, that's going to cost us a bit more because there's 437,000 letters in the Odyssey. We're going to need roughly 1,900 cans of SpaghettiOs.
Was this more expensive than Lord of the Rings?
This is more expensive than Lord of the Rings.
This is more, okay.
Oh wait, no, this is less expensive.
No, it's less. And
I can't do math.
It had even more calories, didn't it?
Yeah, it did. So this is even less than Lord of the Rings. So we can read a classic like the Odyssey and make that out of SpaghettiOs. Not that Lord of the Rings is not a classic. I've loved reading it, but the Odyssey you can argue that's a little bit older of a book. But anyway, you can now apply this. You can use this function on any book that you have the text for and recreate it yourself. Now, and no, if you wanted to make and write it purely out of SpaghettiOs, this is how much you'd need to buy. This is assuming, frequent, like this is like every can has this many A's, B's, C, D's. Of course, we're not taking into account.
We could do confidence intervals on the we could put confidence intervals around the percentage of noodles per can based on the sample.
Leave a comment down below if you'd like to see us calculate a more realistic to tell us approximately how many cans might we really need to really write these out. And we could go through, I don't know, if we got some people to fund us to maybe buy a bunch of cans and actually calculate it ourselves, we might be able to. I'm not promising anything. Tyler said that it was a pain to do it himself, so.
Yeah.
So with that, that's how you can calculate cans of SpaghettiOs to books. How many cans of SpaghettiOs you're going to need per book. Thank you for joining us for episode 179 of TidyX. As always, my name's Ellis Hughes. You can find me on various social media sites at Ellis_Hughes.
And my name is Patrick Ward. You can find me on X at OSPPatrick. At tidy_explain is where the screencast is on X. Of course, easiest way to hit us up, YouTube channel, like and subscribe, questions, comments, thoughts, ideas, things you'd like to see down below. And we do have a Patreon page if you are excited about our work and you feel like it's helped your work and you'd like to donate to the show. The Patreon page is open. We are appreciative of anything that you would like to give.
Yeah, or if you'd like us to do more spaghetti accounting. And with that, thank you all so much and keep on exploring your world.